Here is another simultaneous equation that I'll be going through. So we've got two equations here. In my other videos, we had 1y on both equations, which is why it was easier to solve. But for these two equations, our x values are completely different and our y values are completely different. So you can times all of this by 5 so that you get that 5x, so you can solve for y, or you can times this all by 3 to solve for x. So that's what I'm going to do because I like to use the stop method. So I'm going to times that entire top thing by 3, which gives me that, and then I'll be keeping this the same. Those are my two equations. I'm going to draw a line. We have opposite signs, so opposite signs we like to add. So I'm going to add these up. 16x equals 72, then obviously 16x means to times. We want to move the 16 to the opposite side to solve for x, so we'll do 72 divided by 16, 9 over 2. And obviously, you would just keep halving this until you get there, if it was on a non-calculator page. Now we want to solve for y. I'm going to substitute x into equation number 2 because it looks smaller. Then I will move that 3y this way and a 9 there so that I don't have to work with this minus. So 3y will go here and swap with the 9. This means to times, so we will divide all of that by 3. If it was on a calculator paper, you just shove that in the calculator and you'll get your answer. Once that's plugged in the calculator, we get minus 3 over 2. And that would be your answer. So this one will most definitely be in a calculator paper because you have to deal with fractions. Again, there are so many different types of ways of doing this, but I always like to make sure that I've got my x or y the same, use the stop method, and then substitute and get my answer.